Imagine this. You're in a job interview. You feel like you've done a pretty good job of handling the questions that have come your way so far, and you're feeling cautiously optimistic about your chances. Now the interviewer says, "I'm going to show you an example of a database table." And he proceeds to show you, perhaps on a whiteboard or a screen or printed on a sheet of paper he puts in front of you, this table. It is called World Cup Results. He asks you a question. What is the highest normal form this table is in, and why? You take in this World Cup results table, which seems very simple. It's just a list of first, second, and third place finishers in World Cup competitions. Working out what normal form it's in shouldn't be hard. For the moment, though, you're drawing a blank. You learned about normalization and the normal forms in the past, so by rights you should be able to apply your knowledge to the table you see in front of you. But how do you do that? Where do you start? The interviewer is waiting for your response. Now an idea comes into your head, something connected with what you've learned. It's not a coherent thought exactly, it's just a single word, keys. You look closely at this World Cup results table. You're looking for a primary key, but you're not finding it. You would have expected the primary key column headings to be underlined or to have little key symbols by them. And now you have an aha moment. If no primary key is shown, maybe that means there isn't one. And if there isn't one, you can get yourself out of this question on a technicality, because you're pretty sure a table without a primary key violates first normal form. You say to the interviewer, "The table doesn't have a primary key." The interviewer replies, "For this exercise, you can take it as a given that there is a primary key. You just haven't been told what it is. It's fine, though. You can use common sense to work out what uniquely identifies a row in the table." This is an unwelcome turn of events. The easy answer turned out to be the wrong answer. And now you're being called upon to tackle the problem using your common sense, which you hadn't counted on using. Well, all right. Common sense. What uniquely identifies a row? It's not year, because there are multiple entries for a year. It's not final position, because there are multiple rows for each final position. What it could be is year and final position together. Yes, that must be it. The key is the combination of year and final position. Great. But where does that get you? The interviewer wants you to state the highest normal form this table is in. How do you figure that out? You feel like you're forgetting everything you learned about normalization. There must be some obvious issue with this table that you're missing, something that breaks the rules of a normal form. What does first normal form say again? Something about values having to be atomic? And that's when you see it. The date of last match played column has got those day, month, year values in it. Bingo! Because a date of last match played value has 3 internal parts, a day and a month and a year, it's not atomic, so the table violates first normal form. Easy. "This table isn't even in first normal form," you announce to the interviewer triumphantly, and the reason is the date values aren't atomic. You expect this to be met with approval, but that isn't what happens. "Actually," the interviewer replies, "the dates are fine. Try again." Wait, what? What does he mean the dates are fine? They're not fine. Does this interviewer even know what he's talking about? Non-atomic values are forbidden. That's what first normal form says. To be normalized, a table has to have the day and the month and the year as separate columns. Doesn't it? Or does it? Now you're starting to doubt yourself because it's just dawned on you that you've done exercises in the past where you actually have modeled database tables with dates in them, and you've never split them across 3 columns. You've always just used a single column with a data type of date or date time or whatever, and that seemed to be fine. Data types like date probably wouldn't exist if you weren't supposed to use them. In fact, there must be millions of database tables out there with a date of birth column that has one of those date data types. Maybe the interviewer is right. Maybe a date value really is atomic, After all, numbers are atomic, even though they can be made up of multiple digits. This line of thought isn't helping you, though. You're just wasting time by turning your failed answer over in your mind rather than moving on. It does feel like you're spending a very long time on this question, even though, in reality, probably only 20 seconds have passed. Okay, the date isn't the thing to focus on. Maybe the thing to focus on is the team column, the one with values like France and Croatia. If the table keeps spelling out the full names of those teams every time they crop up, that's bad, right? Redundant. It must be that team needs to be a table in its own right, with team ID as the primary key. And then, in the World Cup results table, we should ditch the team column and replace it with a team ID column that points to the team table. Great. Now the only thing left is to figure out which normal form is being violated. Second normal form? Isn't that the one about not being allowed to have a dependency on part of the key? Let's see. The key is the combination of year and final position, and team depends on the whole key, so the table is in second normal form. All right, what about third normal form? That has to do with transitive dependencies, doesn't it? Does team have a transitive dependency on the key? It doesn't seem to. So there's no problem? But how can that be? If there's no problem, why did it seem like the design had to be split into two tables? You're conscious that you really are taking longer than you should to answer this question. The interviewer is still waiting patiently. His face is hard to read, but do you detect a flicker of pity in his expression? You need to say something, if only to break the silence. I'm just thinking, you say. It occurs to you that you could give up. You could just say you don't know. The trouble is, normalization is one of those fundamental topics that every data person is supposed to be familiar with. You don't want to seem clueless. It's such a simple table as well. You need to give some answer. This shouldn't be hard. Normal forms are about flagging up redundancy, so look for redundancy. Maybe it's about dates appearing more than once. Date of last match played is the same for the winning team as it is for the second place team, which makes sense because the last match they played would have been against each other. Where does that get us? It gets us, well, it's not clear it gets us anywhere, because what normal form deals with that issue? Who knows? Maybe none of them. Another dead end. You're half thinking there's no normal form violation here at all, which would mean, what, the table is in third normal form? But why just third? If there really is no violation, maybe it means the table is in fifth normal form? You keep looking for redundancy. Suddenly, it occurs to you, year is redundant. The year column could be removed from the table and nothing useful would be lost because date of last match played tells you the year anyway. But then again, how can year be removed? Year is part of the primary key. So if there was no year, what would happen to the primary key? Then it hits you. You could define the primary key as the combination of team and date of last match played, which would mean year is dependent on just part of the primary key, date of last match played, which would mean the table violates second normal form. That's it. That's the answer. Okay, I've got it, you say to the interviewer. Team and date of last match played combine to make the primary key. Year is dependent on date of last match played, which is just part of the primary key. So the table isn't in second normal form. So the highest normal form it's in is first. You're feeling quite proud of yourself for getting the answer in the end. This feeling doesn't last very long, though, because the next thing the interviewer says is, "I'm sorry, that's not correct." And he proceeds to give a brief explanation of why it's not correct. But you can't really take in what he's saying. You're too dazed. You thought you understood normalization reasonably well, better than most people, in fact. You thought you knew enough to stand out from the crowd, but it seems like actually you understand nothing. How else can you account for the fact that a simple question about a simple table left you floundering? And if you don't understand normalization, what other things do you not understand? How much else is there that you think you know that actually you don't know at all? You muddle your way through the rest of the interview. You don't end up getting the job, and although the reasons for this go beyond your wrong answer to the normal form question, It's safe to say the wrong answer didn't help. You make some half-hearted efforts to brush up on normalization so you can do better next time, but it doesn't last. Every article or web page or book chapter you read on the subject just leaves you more confused, not less. It makes you cynical about the whole business. You say to yourself, normalization is stupid. It doesn't make any sense. It's confusing. Nobody seems to be able to explain it properly. It's not clear what the point of it is. People can't even seem to agree whether it's good or bad. One moment you'll hear that good design is about putting your tables in third normal form. The next moment you'll hear that good design is about avoiding third normal form. And from then on, you just put normalization out of your mind. Eventually you do land a role, not your first choice, but a role nevertheless. It involves some relational database work. At your new job, when you design tables, one thing you never think about, even for a moment, is the normal forms. No doubt some of your tables are normalized and some aren't, but it's not a distinction that concerns you. So long as you've captured the data the users want you to capture, you've done your job. Everybody's happy. Well, maybe that's going too far. It would be a stretch to say the users are happy. But users just are that way. They're always finding something to complain about in the data, some gap or inconsistency or problem. You're forever reworking what's already been done. That's life, though, isn't it? Data is messy. Here ends our little story. There's a lot that can be learned from it, but let's start by analyzing the table that caused all the trouble. Let's determine the highest normal form the World Cup results table is in and why that's the case. Step 1 in analyzing the table is to work out its keys, not just a key, but all the candidates that could possibly be chosen to be the primary key. In this case, there are 4 candidate keys: the combination of year and final position, the combination of year and team, the combination of date of last match played and final position, and the combination of date of last match played and team. Examine any of these 4 and you'll find that it's guaranteed to uniquely identify a World Cup result. Step 2. Find the non-key attributes. These would be attributes that don't belong to any key. But in this case, there aren't any non-key attributes. Every attribute in the table belongs to some candidate key. Step 3. Evaluate the table against the normal form definitions. A table violates second normal form when it has a non-key attribute that depends on part of a key. But since there aren't any non-key attributes in World Cup results, there's nothing that can cause a violation. It's the same with third normal form. A table that's in second normal form would violate third normal form if it contained a non-key attribute with a transitive dependency on a candidate key. But again, the table doesn't have any non-key attributes, so there's nothing that can cause a violation. Conclusion: the World Cup results table is in third normal form. Can we go any higher? Let's check the table against Boyce-Codd normal form, which is the normal form that comes after third normal form. This is where the dependency of year on date of last match played finally does get flagged up as a problem. And this is because, loosely speaking, Boyce-Codd normal form doesn't allow any attribute to be dependent on something that isn't a candidate key. Date of last match played isn't a candidate key, so the table isn't in Boyce-Codd normal form. Therefore, we can confidently say the highest normal form of the World Cup results table is third normal form. The problem isn't that this analysis is difficult. The problem is you're not necessarily aware that this is the analysis you need to do, and the likely reason is that the normal forms weren't taught to you correctly. Instead of being given a solid understanding of the normal forms, you've been exposed to a collection of vaguely normalization-related ideas, some more relevant than others. Over time, these ideas have formed themselves into a sort of soup in your brain. This doesn't help you. An idea soup isn't a robust basis for answering interview questions with confidence, or demonstrating real understanding on an exam, or, most crucially of all, doing real database work and doing it well. The solution? Start over. Forget everything you think you know about the normal forms. Get hold of their actual definitions, study and understand those definitions, understand all the concepts that appear in the definitions, and don't be distracted by anything outside those definitions. The hardest part of this isn't the studying or the understanding, it's finding an explanation of the normal forms that you can rely on, because the internet is a mine of misinformation about the normal forms. And, as we'll see in a few moments, AI chatbots tend to reproduce the misinformation. The leading relational database theorist, Chris Date, wrote what I believe to be the best and most comprehensive book about the normal forms and all that jazz. It's very theoretical, very detailed, and unfortunately, very much not for the average person. I've searched for a long-form guide to normalization and the normal forms that I could recommend, one that's not only reliable, but also pitched at a level suitable for everyone, from complete beginners to people who've been working in data-related jobs for years. I couldn't find one, so I wrote my own, a Decomplexify Guide to Normalization. When writing it, I had a few goals in mind. Make it simple. Make it accurate. Have it devote special attention to the areas where people commonly go wrong, like the atomic values pitfall the job applicant fell into in this video. Don't assume prior knowledge. Don't make people plow through huge amounts of theory before they can even contemplate applying the material to the real world. Through the traditional Decomplexify method of proceeding step by step and using lots of examples, the book aims to take you from here, the idea soup stage that perhaps you're currently in, to here, mastery of the principles of normalization and the ability to use them to think clearly about whatever real-life data problems are thrown at you. This clarity of thinking about data is what will set you apart from the crowd, allowing you to tackle even very complicated analysis and design work in a way that cuts through the complexity and gets to the heart of the matter. If you're the sort of person who doesn't want to spend your time sifting through lots of conflicting sources of information to piece together an understanding of the topic, if you'd rather have everything you need to know about normalization laid out from start to finish in one place, this book was made with you in mind. You can click on the link in the description to get hold of a copy. One last thing. I mentioned AI chatbots. In the course of making this video, I asked 3 different AIs the question we've just been exploring. What is the highest normal form the World Cup results table is in? These 3 AIs gave me 3 different answers, all of them wrong. ChatGPT said first normal form. Claude said second normal form. DeepSeek said voice cod normal form. Each AI went on to change its mind with varying degrees of reluctance when the errors in its reasoning were pointed out to it. A helpful reminder of the dangers of placing too much trust in large language models, which, although they can mimic thinking very convincingly, can't actually think. This limitation is also an opportunity. The world, including the world of relational database work, still needs people who can think clearly and deeply and devise creative solutions to problems. I hope you found all this helpful. Please hit the like button if you did. If you have any comments or questions on what you've just heard, please go ahead and post them in the comments section below. If you have any suggestions for complex topics that you'd like to see explained on Decomplexify, let me know in the comments. And as mentioned before, you can use the link in the description to grab a copy of the book. So long, and thanks for watching.